Okay, so we're going to put together all of these tests that we've learned for testing series and think about if I give you a random series and it didn't appear on the worksheet with alternating series or something like that, then how do I know what test to do? Where do I get started so that I don't waste a lot of time? And so that's what we're going to do today. We're going to get a lot of practice with this. So the first thing to do is really to try and think about whether we can classify the form of the series instead of just going down a checklist of different techniques. And so we're looking at it and we're saying, well, does it look alternating? Is it obviously a test for divergence? Does it look like it's a root test? And so you're trying to see if you can think of what the form looks like before you do anything else. And then start there. So we'll come back to this list in just a second, but let's look at these down here. So we have 1 over n squared plus 1. That looks close to a p series, but that plus n is kind of messing with us. So this one might be a good comparison test. This one looks like something that I could compare. So maybe the form of this one is a good comparison test. This next one down here, when I look at this, always think test for divergence really quick. This one looks like a test for divergence is going to work on it. So that's what I would start with. Number 3 is alternating. So I'm going to start with alternating series test on that one. Some alternating series, a root test or a ratio test will be better on. This one doesn't look too complicated, so I think alternating series might help us. And then number 4, at first glance, it looks geometric because it has things being, or like the 2 to the k and the 3 to the k plus 1. But then we see that denominator has the k to the k. So this one's not going to be geometric. Since everything has a power, I would maybe try the root test on this one. Okay, so we'll come back to these 4 in just a second and probably try all those tests that I just talked about. But let's go back through our list of different tests and just kind of think about how would we get started. So like I said a minute ago, try the test for divergence first, but don't actually write out all the work, okay? So you can look at these. Most of the time you can figure out whether the test for divergence is going to work right away or not. So if you can look at your problem and say, nope, that limit's going to be 0, then don't do any work for the test for divergence because the test for divergence won't tell us anything. So like problem 1 down here, I look at that, I see, oh, that's going to be 1 over infinity. That's going to be 0. Test for divergence doesn't tell me anything, so I'm not going to write any work down for that. Okay, so only do test for divergence usually if it's like kind of obvious that that's what it's going to be, or in those cases where we start out thinking it's an alternating series and then it turns out to be a test for divergence. Okay. If you can tell that the series is obviously a p series or obviously a geometric series, well, then use that. Most of the time, we're not going to get easy examples like that anymore. Then again, can we see a series that looks like an easy comparison test? Does it look like it is similar to a p series or similar to a geometric series? Then we can try one of the comparison tests, either direct or limit comparison. You have to remember that these, for the comparison test, you can only have positive terms. Again, do you have a rational function, so like a polynomial over a polynomial, or even a polynomial that's under a radical? Again, try a comparison test. Usually the limit comparison will work better than the direct comparison there. Root and ratio test won't work on cases like that, so you want to stick with a comparison test. And then if you have factorials in there, ratio test is going to be what you want to try. If you see a factorial, try the ratio test. And then let's see, alternating series. If it looks like it's alternating, try the alternating series test. And then again, if you have things raised to the nth power, try the root test. And if nothing else works, try an integral test, especially if it looks like it's an integral that will be easy to compute. Okay, and so why don't we go ahead and try these examples below. I also realized that earlier I didn't scroll all the way down. There's a problem 5 I missed. So let's look at this first one. This first one I said, it looks like a good comparison test. So to use the comparison test, we have to check that the terms are positive, and indeed the terms are positive here. So that's good. And so let's try comparing this to 1 over n squared. This is a convergent p-series. As always, you guys can spell better than I can, since p is 2, which is less than 1. Okay, and so let's see, you could probably try a limit comparison here. I'm going to try a direct comparison. We'll see if the direct comparison works. So I do 1 over n squared plus n, 1 over n squared. Which one's bigger? This denominator is bigger, so that fraction is smaller. Our terms are smaller. Than those of a convergent series. So by the direct comparison test, our series converges. Okay, it's a lot to write, especially while you're watching me tape here or write, but you want to make sure to write out all that detail. Okay, you guys should really try these rest but without me, but I'll go ahead and do them. I'm going to do them in the most efficient way I can see possible. You might try other things and you might find something else that works, and that's great. Like I said, this one looks like a great candidate for a test for divergence. When I look at this, I very quickly see that the highest power in the numerator and denominator is n over 2n. That simplifies to 1/2. So this limit is not going to be 0. Okay, that's the work I do in my head. Now I have to write that all down. So I'm going to look at the limit as n approaches infinity, n plus 2 over 2n plus 7. Again, that's going to boil down to the highest power from the numerator and denominator. So n over 2n, that simplifies to 1/2. 1/2 is not 0, so this diverges by a test for divergence. Awesome. Okay, again, this next one looks alternating. Well, it is alternating. So I'm going to try the alternating series test on this. So if I try the alternating series test, definitely alternating because of that -1 to the n. Okay, when I do the alternating series test, there's 2 more conditions we have to check. We have to look at the positive piece and see if the positive piece is decreasing and if the limit is 0. I always start with the limit because if that limit doesn't work out, then I can try a test for divergence. So I'm going to look at the limit next. So again, I can look at this limit and I can tell you that that's not going to be 0. So alternating series test is not going to help us here because we look at the highest power, the n squared over n squared, and that simplifies to 1. That is not 0. Alternating series test needs me to get 0 out. So we cannot use alternating series test. That's okay. A failed use of the alternating series test is actually quite helpful because now we try the test for divergence. When we apply the test for divergence, we have to look at the limit of the original series. So we're not looking at the same limit, but that limit helps us. So if I look at that limit of the original series, we see that some of the pieces are going to be going to +1, some of the pieces will be going to -1. This is going to be bouncing back and forth between 2 values, and so this overall limit will not exist. Does not exist is not 0, so this diverges by the test for divergence. Okay. Awesome. Let's keep going. There's that problem 5 that was hiding below. Okay, so before I said let's try a root test on this one because of that k to the k in the denominator. So I'm going to look at the limit as k approaches infinity, the nth root of the absolute value of 2k to the k 3 to the k plus 1 over k to the k. Okay, lots of k's in there. And so that'll give us a limit as k approaches infinity. Well, this should be the kth root. Sorry, guys, because k's are variable we're using. Okay, so the denominator, k to the k, when I take the kth root of that, this k is going to go away. So I'm just going to be left with a k. Similarly, up here, we'll just be left with 2. I like to think of 3 to the k plus 1 as 3 to the k times 3 to the first. So the 3 to the k will just become a 3. 3 to the first will become 3 to the 1 over k, since the kth root of 3 to the first, that's just 1 over k. That's how we rewrite kth roots. Okay, so as k approaches infinity, 1 over k will go to 0. So 3 to the 0 will go to 1. So my numerator is just going to be 6. I'm going to have 6 over a big number, which gives me 0. The root test tells me if I get something less than 1, then my series converges. So this converges by the root test. Okay, this video is a little bit long, but I think it's good to see a lot of examples, and hopefully you've tried some of these on your own. This last one has a factorial in it. Seeing a factorial always tells me to try the ratio test. So I'm going to try a ratio test here. So I'm going to look at the limit as n approaches infinity. My n plus 1 term is 9 to the n plus 1. I'm going to replace this n with n plus 1, so I'm going to end up with n plus 2 factorial in here. I divide that by the normal nth term, which is the same thing as multiplying by the reciprocal. So I'm going to multiply by n plus 1 factorial over 9 to the n. And now I just have to simplify. The 9 to the n plus 1 is the same thing as 9 to the n times 9 to the first. So the 9 to the n's are going to cancel out. I'll be left with a 9. Remember that when the factorials, n plus 2 factorial is n plus 2 times n plus 1 times n, so forth and so on. N plus 1 factorial is n plus 1 times n, so forth and so on. So the n plus 1 and down will cancel out, and we'll just be left with an n plus 2 in the denominator. That whole thing will be equal to 0, which is the same as the above example. So 0 again is less than 1. Root test and ratio test have the same conclusions. So this will again converge because 0 is less than 1. It's going to converge by the ratio test this time. Okay. So hopefully that was some good practice. I think it's good to hear my thought process as I go through these. And really, like I said, try to do the least amount of work you can possibly do. So don't sit here and think, oh, test for divergence. Is it an alternating series? Is it a p-series? See if you can try and identify that general form of the series before you jump into testing the various pieces.